In this lesson we're going to continue with integration, and this time we're going to look at definite integrals. So we've previously looked at indefinite integrals, and we know that those had a constant of integration, and that was one of the features of indefinite integrals. So let's have a look at what definite integrals actually mean. So let capital F of x be the integral of f of x, if you like. Okay. So we would define the integral between a and b of f of x with respect to x to be equal to the integral of f of b minus the integral of f of a, where a and b are the limits of the integral and b has to be greater than a. So for example, if we have the integral between a and b of x with respect to x, we would get x squared over 2 plus c. But we want to integrate between a and b, so we now need to substitute a and b into our equation, the integral that we've got. Okay, so that would give us b squared over 2 plus c minus a squared over 2 plus c. Now you'll notice here that I'm substituting in b first. That is the bigger number numerically, the bigger limit, if you like. Okay, so we can then see that our constant of integration c will simplify to 0, and it leaves us with b squared over 2 minus a squared over 2. And we know that for indefinite integrals we always need the constant of integration, but here, like I said, it simplifies to 0, so it's not actually required for definite integrals. Okay, so let's look at an example. We want to find the integral between 1 and 3 of 5x squared with respect to x. So integrating gives us 5x cubed over 3. I'm putting a square bracket around the integral that I've got, and I'm putting my limits at the side here. I've got 1 up to 3. Now, I'm now going to take my 5x cubed all over 3, and I'm substituting 3 in, and I'm then subtracting the 5x cubed all over 3 when I've substituted 1 in. Now, this gives me 135 thirds minus 5 thirds, and altogether I have 130 thirds, or I could change that to a mixed number if I liked, and that's 43 and 1/3. So just to summarise, I have integrated my function, and then within this integral I have substituted in my upper limit, and then I've substituted in my lower limit, and I've subtracted these. So I'm trying to find the difference between the integrals with each of the limits, the integral with each of the limits substituted in. So just now would be a good time to pause the video and take this example down in your notes jotter before coming back for another few examples. Okay, welcome back folks. So now for example 2. And we want to find the integral between 0 and 2 of x cubed plus 3x squared with respect to x. So as always, we're going to first integrate this function, and it's ready to be integrated at the moment. So that will give us x to the power 4 all over 4 plus 3x cubed all over 3. And I have integrated that. My limits are 0 and 2 here. So I need to remember and put that in. So I can also see here that my second term, 3x cubed over 3, can simplify to give me just x cubed. So I've got that, and I'm now going to take this expression and substitute in 2, and then subtract the same expression when I have substituted 0 in. So that's me substituting in my 2 and subtracting the same expression with 0 substituted in. Now hopefully you can see from the first bracket I will get 4 plus 8. The second bracket will give me 0. So my final answer here is 12. So just now would be a good time to pause the video and take this one down in your notes. We've got another 2 examples to have a look at. Welcome back, folks. We'll have a look at example 3 now, and we want to find the integral between -1 and 4 of 4 over x cubed with respect to x. Now, hopefully when you see this, you'll realise that it's not quite ready to be integrated just yet. So we need to re-express 4 over x cubed as 4x to the power -3. So we're integrating between -1 and 4, 4x to the -3 with respect to x. So adding 1 to the power is -2, and then we need to divide by -2. So it's 4x to the power -2 all over -2, and you can see that my limits were -1 and 4. Now, before I do any substitution here, I need to express that with positive indices again, in the event that I don't have a calculator. Even if I do have a calculator, I should be expressing it with positive indices. So 4 over -2 is -2, and the x to the power -2, if we move that to the denominator, we can express it as x squared. So it's -2 over x squared, and we're going to substitute in 4 and then subtract the same expression with -1 substituted in. So we get -2 over 4 squared minus -2 over -1 squared. First bracket gives us -2/16 in the first instance. The second bracket gives me -2, so it's -2/16 minus -2. I can see that -2/16 simplifies to -1/8, and I'm subtracting -2, that's the same as adding, so -1/8 plus 2 is 15/8, or 1 7/8. So you need to make sure for non-calculator papers that your addition and subtraction of fractions here is tip-top as well. And now we'll have a look at example 4, which is slightly different. We want to find the value of z for which the integral between 1 and z of 1 plus 2x with respect to x is equal to 4. So we've already been given what we've had in the last 3 examples we've known as the answer, and this here is 4, we're already given that. But in the last 3 examples we were also given both limits, but here we've got an unknown limit of z. So we need to take that into account here. So let's start off, we need the right hand side as well. So we're writing that fully, and we're going to start integrating the left hand side. So we get x plus 2x squared over 2, and we're substituting in z and 1 into that, or 1 and z rather, and we still know that that's equal to 4. Okay. Now I can simplify my 2x squared over 2, that gives me x plus x squared, and again I've still got my limits here, 1 and z, and I know that all of that is equal to 4. So I'm going to substitute in z firstly, that gives me z plus z squared, and then I'm subtracting that same expression with 1 substituted in, so 1 plus 1 squared, and I know that that's equal to 4. That gives me z plus z squared minus 2 equals 4, and I'm starting to see that I've obviously got a quadratic equation here. In order to solve quadratics, I need one of my sides to equal 0. So I'm going to subtract my 4 from both sides to give me z squared plus z minus 6 equals 0. Now factorising will give me z plus 3, z minus 2 equals 0. And z I can see is equal to -3 and 2. So I've got 2 options for z. Now, if I look at the limits here, I was given 1 and z. Now we know that because z is the upper limit, that it has to be greater than 1. So z can't possibly be -3 because it's not greater than 1. Okay. Z could be 2, or it can be 2, and it is 2, because that is greater than 1. So z is equal to 2 since z is greater than 1. So before the screen goes blank, pause the video, copy the example down, and try the assigned exercises for today, please.